Lakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the eigenvalues, eigenvectors of a real matrix. Let A equal to Aij be a square matrix. The characteristic equation of A is determinant of mod A minus lambda I equal to 0. The roots of the characteristic equation are called as eigenvalues of matrix A. If there exists a non-zero vector, then x equal to x1, x2, etc. such that Ax equal to lambda x, then the vector x is called a eigenvector of A, the corresponding to the eigenvalue of A. So, based on this, you can calculate the problems. So, first given is find the eigenvalues and eigenvectors of the matrix 1, 1, 3, minus 1. So, first find the characteristic equation determinant of A minus lambda I equal to 0. That is, if it is a 2 cross 2 matrix, so you get the quadratic equation. So, lambda square minus C1 lambda plus C2 equal to 0, where C1 is sum of the main diagonal elements. Here the main diagonal elements are 1 and minus 1. So, 1 and minus 1 multiplying, adding these two, you get 0, and then C2. C2 is determinant of A. So, the 1, 1, 3. So, first cross minus next cross. The answer becomes minus 4. So, next we can substitute these two values in the given equation. So, if we substituted all those values, we got the answer as lambda square minus 4. So, this is the cubic equation got. From this, we want to calculate the eigenvalues. So, lambda, take the equation lambda square minus 4 equal to 0. So, after this lambda squared is 4, then lambda equal to plus or minus 2. From this lambda equal to plus 2 and minus 2. So, we got that for the quadratic equation we got the two roots. So, next we want to calculate the eigenvectors. So, eigenvectors, first general term we want to write. So, the general term is A minus lambda I into x equal to 0. So, A value and then minus lambda into that I matrix into x equal to 0. So, concluding these terms, we get in the diagonal alone, write the diagonal values 1 and minus 1 with this minus lambda, you write it. After this, you can move on to the step-by-step process. So, first case 1, lambda equal to 2. So, instead of this lambda is just replaced by 2. So, 1 minus 2 and then minus 1 minus 2. So, conclusion of these two terms we got minus 1, 1 and 3 minus 3. So, these four values we got, which is equal into x1 x2 which is equal to 0 comma 0. After this you can write it as one equation. So, first row with first column and second row with first column. So, we got minus x1 plus x1 x2 equal to 0 and then second row 3x1 minus 3x2 equal to 0. So, from this first equation we got a x1 is equal to x2. From the second equation also check it, x1 3x1 equal to 3x2. We can cancel this 3 x1 equal to x2. So, whatever it is, from these two equations got a answer as x1 divided by 1 and x2 divided by 1. So, therefore, the x1 is 1 comma 1 1. So, we got the first eigenvalue. We move on to the next eigenvalue. So, lambda equal to minus 2. Substituting lambda minus, so minus of minus it becomes plus. So, 1 plus 2 minus 1 plus 2. So, these values we got it. So, after this directly we got an idea it is the same equation. So, if it is same equation you want to take only one equation. That one equation is 3x1 plus x2 equal to 0. It is enough to take the only one equation. So, 3x1 plus x2 equal to 0. Take this x2 to the right side. So, 3x1 and the coefficient of x2 is 1 minus 1 and the coefficient of x1 is 3. So just to take it to the denominator of the opposite term. So from this x1 is minus 1 and x2 is 3. So this way we got the values of x1 and x2. So we can write the final conclusion for x2 is minus 1 and 3. So we can write in small tabular column. So eigenvalues 2 and minus 2. The corresponding eigenvectors are 1, 1, minus 1 and 3. So thank you.